Hello and welcome to another Coffee with Developers. I'm joined by two people today, Andrew Burnett-Thompson and David Burleigh, CTO and CEO of the founder of SideChart. You might not have heard of SideChart yet, and the thing that fascinated me most about it was when it comes to performance, we always think like computer games are like the top-notch thing that needs performance, especially when AAA games get ported to the browser and they always are slow as hell. But then I realized charting is actually an uncharted territory in terms of performance. So it seems like what you do is really on the bleeding edge of making things work in browsers and also on the web. So quickly introduce ourselves to what you do. Like I basically as the CEO starts, Andrew, what does SideChart do and what do you do for SideChart?
Right. So SideChart is basically a high-performance charting library. It was given the name SideChart because it's literally scientific chart. And initially, we targeted scientific, medical and financial industries. But now we're seeing more and more usage across enterprise business. Lots and lots of different types of industries use our library in order to draw dashboards, draw data visualizations, 2D charts, 3D charts, all the kind of things that you'd expect in a charting library. With one difference, we do it incredibly fast. So SideChart can handle millions of data points in the browser. You can have hundreds of charts. You can link those charts together. And we've pushed the edge of performance of what you're able to do by utilizing a lot of different technologies, such as WebGL, WebAssembly, etc.
Mm-hmm. So basically, you promise performance, and David Burleigh, as the CTO, has to deliver it. So when people talk about charting, we normally think about like, okay, some colorful things and maybe some animation, but it seems like what you're showing, especially on the SideChart page, if people want to go there, just go and see the demos that are happening there, that's a whole other level. So David, what was the most taxing thing you had to show as a chart, and how did you approach that?
I think the issue is not just one chart. It's what happens when you've got many charts and huge amounts of data, and you're trying to put it all together. And also, it's not just, hey, I want a big standard line chart. It's like I want that, but I want thresholds, and I want tooltips, and I want the interactions, and I want when I zoom and pan, it does this, and when I click, I can get the data out and put it somewhere else. So it's all of that together.
It's interesting because I mean, when I look at chart libraries and I get all these offers like, do you want this chart or that chart? I have no idea what they are. But when I started to do them myself, it was so much fun because math in school is not fun. But putting math and data together and then showing it is a really, really cool thing to do. And it feels so good to actually find out, make sure that it scales with data and these kind of things. So, I mean, you've been breathing that for quite a while. How long have you been doing that? Like, how old is SideChart?
If I take that question, so SideChart actually started, the first version was built in 2011. It's a completely homegrown business. So it's something that I started off myself, pretty much in my living room. And the first version targeted WPF. And what we tried to do was say WPF was notoriously slow. It was the de facto standard for thick client apps. It was used in banking. It was used in enterprise, et cetera, et cetera. But, it was pretty slow because of XAML. So what we tried to do was say, well, can we not render the chart using raster graphics, for instance, drawing directly to a bitmap, and then mix that with WPF? And that was the first version, and SideChart WPF immediately became popular in scientific communities because they were like, yes, we've got lots of data to show. When will this be available? And from there, we just grew and grew the business. Over the years, so we've been going almost 15 years now, we've added a mobile version. We've added a version for iOS and Android. We've added a version for Mac OS. Now we have SideChart.js, which is JavaScript in the browser. This is using the same technology under the hood as our WPF charts. So we have a C++ layer, which we compile into WebAssembly, which allows us to do some, pretty cool things really that you can't do with just vanilla JS. So yeah, I mean, been going for a long time, been growing organically for a long time. And here we are. We now have this product on the web that can give you near native performance in the browser.
So, David, back then, I mean, Andrew just said that WPF was the standard, but I always found it like to be, as a web person, it always came to me like, okay, XAML and these kind of things and Xamarin, then later on, and it was just the problem that I had with WPF is that it wasn't cross-browser, cross-platform, but it felt like I came from a Flash environment as well, where charting, of course, was a big thing as well, but that needed a plugin, and it was not native at all. Like, what made you choose WPF, and how did you feel about like the platform moving, not being front and center any longer in terms of support?
I think initially the people with the biggest data requirements were on WPF.
Okay.
Back 10, 15 years ago, nobody was pushing millions of data points into the web. It just like modems, right? So you had to. It was only on thick client applications that desktop apps that you had that, and so that's where this performance requirement came from. And all of these kind of cross-platform things really didn't exist at the time. They've kind of developed over the years, we have. We've looked at them. We supported Silverlight for a while when that was available. Loved that technology. We dabbled with Xamarin support for the as a wrapper around the mobile stuff. We've seen a lot of these things come and go, and we've found it's always been very difficult and time consuming to build the necessary kind of wrapper layers around the thing. A lot of these cross-platform libraries work by saying, oh, we want to create a mapping between some high-level representation of your app and the native components that exist on all of those kind of things. And that's a lot of work. And actually, a lot of the times that mapping doesn't allow you to expose all the things that you want to expose, especially when you're dealing with like really, low-level stuff. And so, we found it very difficult the support for what we're doing in SciChart isn't really there in things like React Native and Flutter and that kind of stuff. You can kind of do it, but you lose the benefit of the cross-platform stuff. So what we think actually is the better thing is take all of the platform stuff away and just say, let's just have a canvas and an event source, and we'll do everything. And then that's what people have been doing in the games world for ever and ever, right? And then you really can run it, anywhere, and especially with WebAssembly, anywhere you can run a GPU accelerated browser and a canvas, you can show the whole thing. So we think that's really the future of cross-platform. That's what we are pushing towards. We're trying to put more and more functionality into that native layer, so that more and more of this stuff can be accelerated. The challenge is people don't just want performance, they also want flexibility. They want to be able to customize every element of the chart. And that means you want to be able to get out of the native stuff into the platform layer. I want to be able to have, custom annotations and custom UI elements that control the chart and do various things. And so, we're constantly pulled back to the platform specific stuff by those needs. So we're still, and I think we're always going to exist between those two worlds where, you always have to make some compromises for cross-platform, and we'll do that. But we also want to cater for the people that really have very, very specific requirements and are willing to embrace those platform specifics in order to get exactly what they want.
Mm-hmm. I mean, going your conversion route to actually start with C++ and then use Emscripten and WASM to actually get into the web platform and any other platform there is actually a rather clever way, because C++ is already optimized for it. And as you said, if we were to use React Native, you would have the whole performance blocker that is React Native on there before you can actually test your platform, your performance of your tool itself. So I think that is an interesting way. And when Emscripten came out, when we did it for Firefox OS back then, I was like, okay, that's going to be interesting. And then Blazor came out for like .NET applications to turn them into JavaScript. And it's quite fun because when you start with JavaScript or TypeScript, you have the problem that everything is everything. So a thing is an object, is a string, can be coerced to everything else, and that costs a lot of memory. Do you find that by starting with C++, you work around that issue?
Yeah, if I can answer that. So, I mean, JavaScript, you asked the question earlier, why not focus on that first? I mean, the performance wasn't there. I remember in 2015, we were working on SciChat-WPF, but also mobile, native mobile. And people were saying to us, hey, can you make this work in HTML5? And we said, all right, we're going to test one of our algorithms, just one of our data processing algorithms in JavaScript in the browser. It was 100 times slower than native code. And we were like, this is impossible. We just can't get there. We can't deliver what you want, But when Inscription came out, so we started developing SciChat.js in about 2019. And we were like, hang on, we can take our existing C++ code, which we know is battle tested on Windows. We know it's performant. And we can now target the web, right? Underneath, there's actually, there's basically a lightweight game engine underneath in SciChat. And it's sitting there in the C++ layer. So all of the, the abstract types that let you talk to the GPU, compilation of shaders, vertex buffers, et cetera, those have already been made cross-platform to OpenGL, WebGL, OpenGL ES, DirectX, et cetera. So we were like, can we compile that? And the answer was yes. It took a lot of work, right? It was, if I'm honest with you, it was somewhat miraculous. And that allowed us to bypass certain problems, So you talked about everything is, an object is anything in JavaScript. One of the problems is not just memory, it's boxing and unboxing. If you have vars and const and arrays and you're throwing numbers in there, JS number, when you want to iterate over those numbers, they're all boxed, right? Whereas what we want is we want a continuous block of memory. So float64 array now addresses that in TypeScript. But in WebAssembly, we have a continuous block of memory. So we say, right, this is our X values, this is our Y values. And now we can do all kinds of tricks. We can do pointer arithmetic. We can scan it very quickly. We're even experimenting now with enabling, some of the new things that have come out in WebAssembly, for example, WASM SIMD. So by turning that on, we can actually use single instruction, multiple data instruction sets in the browser on the memory that's in WebAssembly. Interoping that between JavaScript and WASM, there was a lot of things we had to work around in order to make that work fast, because what we didn't want to do was do a copy and then a copy. Does that make sense? Because that would also be a performance bottleneck. So yeah, I think that from a technology point of view, Inscription and using C++ has enabled us to do a couple of things. One of which is code sharing between our platforms. But the other one is so a unified experience for our users. But the other one is to enable the highest possible performance with data manipulation, data preprocessing, and rendering that we can.
Mm-hmm. I remember when the iPad came out and out of a sudden Flash was dead and everybody said like that's the future and everybody's going to use their mobile phone for everything and your day is going to start with Siri and end with Cortana and none of that came to us, but at the same time I was asked to do Yahoo Maps back then to turn them from Flash into JavaScript and have the same performance, and also on mobile. How do you make something like Maps work on mobile in the browser back then? And my biggest problem was like having to deal with expectations of users. So in your case, did you find the same thing? You said you have a mobile version as well right now. Is that a lighter version of it, or is it something where you can say like you could do all the magic that you see on your mobile as well?
It's the performance there is as good. It's only limited by the power of the device. You're right about the expectations thing, though, and we get this. We have the problem on both ends, right? On one sense, people take a long time to find us because they don't even think that what they're trying to do is possible on the web. And when they find out what it's possible, they're like, they're like, oh, we have this chart, and at the moment it takes 5 seconds to refresh, and we think if we could get that down to 1 second, the users would be really happy. And we kind of do the thing and say, well, you could run that chart at 60 FPS in SideChart. What are you talking about? And they're like, what? So there's that expectation. But then on the other hand, we get people early on. We had support requests coming in saying, oh, we found a memory leak. We're seeing some slow memory growth and the chart crashes after a while. Well, how long? Oh, 3 days. What? You've had a single tab open continuously running a real-time charting application for 3 days. I have to restart my laptop every day, otherwise it bugs out. What is this? That's not what the web was designed for. What are we doing here? But we rolled up our sleeves. We wrote a whole layer within SideChart where if you turn it on, we proxy every native element that we create, so we can track its creation and destruction and garbage collection and give you an absolutely full report of all the native memory usage. And then we went through and we eliminated every leak that we found. And now we can run it for days, and our customers can run these things for days and days and days, with flat memory growth. And it's like, we didn't think that was possible. But if you're really careful, it can be done. So there's a lot of problems with the browser. The greatest strength of it, the fact that it's this sandbox that you can solves all of these deployment problems that people have with desktop apps. It's also the weakness, right? You've got to serialize every piece of data that you pass into there, and that slows everything down. So trying to be efficient about that, trying to where do you do your data reshaping, and how do you get the data into the kind of the efficient format that SideChart's going to need. All of that kind of stuff is very interesting. But it's we've been surprised, and our customers are constantly surprised about how much you can do if you're prepared to think about it in the right way.
And I mean, the other, of course, is you're never alone in the browser. You're one of several tabs. That's the other thing. Something else can actually take over half the machine without you knowing it. And that's where React apps come in quite heavily. I mean, when I worked on Edge, it's like we did that sleeping tabs feature that allows us to actually not use up memory while things keep loading and these kind of things, to get like the page activity API to make sure that you're only doing things when somebody's looking at it. But yeah, people just nowadays, I guess with machines being so fast, they just think we can do it. Just show it on a 4K screen in front of our office with like an old laptop and one Chromium instance. But then you realize okay, it will crash sooner or later. But I mean, I haven't rebooted my Mac in like 50 days or something. Plus, you got so used to the machine doing the stuff for you nowadays. Now, when it comes to the users that you said that come up with these kind of needs, what are the people that actually use the most SideChart functionality? Like, who are people that need millions of data points in real time on a screen? Like, what kind of use cases are those? You don't have to mention the companies, of course, but it will be interesting to see what kind of fields they're in. I guess Andrew will be the person to answer that.
Yeah. So as I mentioned, SideChart is used by many industries. We've got a whole section on the website that talks about the industries that use it and what the use cases are. I'll give you some examples. So we know that SideChart is deployed into medical devices. For example, if you have the heart rate monitors in hospitals, you also have giant dashboards that cardiac surgeons are looking at when they're looking at lots and lots of patient monitoring systems, etc. We know that it's deployed in industrial monitoring situations. So these would be factories, refineries. We know it's used in oil and gas exploration. And that could be a user interface that is looked at by a scientist or somebody in order to monitor drilling or exploration activities. But it's also used in enterprise. It's used in business. We have lots of commercial entities. We have entities in banking using SideChart, quantitative trading. Formula One is an enormous one as well. Like we like to talk about that because it's very niche, but it's kind of cool. So pretty much all of the Formula One teams use SideChart in one shape or form, and that could be anything from wind tunnels all the way through to pit strategy management software. So these are really, really demanding use cases. You're not talking about an app where, you pull up your app and you've got a pie chart and a column chart and you've got 20 data points on it. You're talking about an app that could have 10, 20, 50, even 100 charts on a dashboard. Each chart could have, hundreds of series. Maybe those series have, 100 points, or maybe they have 1,000 or 10,000 or even 1 million. We've had to go through SideChart on all of the platforms, but particularly on the web, to really aggressively optimize all the possible paths. So displaying one chart with linear axis, with one line, with 10 million data points is not that difficult. But if you want to have 10 of them, and maybe those axes are non-linear, they're logarithmic or scaled in another way, or maybe you have different series types, and then drawing all of those efficiently, plus the user might be interacting with them. They might be zooming and panning one and expecting the others to zoom and pan together. They might be synchronizing a tooltip where they hover one chart and that has to synchronize on the other, like some kind of a timeline control. So yeah, these are the kind of industries and use cases that SideChart is used in. We would say that it's probably not the chart library that you would go to and use if you just want to put up a small number of charts with a small number of data points. But if you have challenging visualization requirements, and especially if you've hit the wall with what's out there, as many people do, these are the types of people that use SideChart, and they really love what we do and they use it enthusiastically.
Mm. Yeah, I want to double tap on that too. Oh my God, I sound like a salesperson. I want to go deeper on that because the market is saturated. There's a lot of free libraries out there. There's a lot of open source libraries out there, and it seems like people come to you when they want industrial strength, or when they have a data format that basically is no other way of doing it. Do you take inspiration from other people as well, or do you feed back to other people in terms of how they can scale, or is this beyond your remit because you're just the two of you, right? Like there's not many more people in the company. How many are you?
No, we have 15 developers at SideChart,
yeah.
And those are split across several teams. So we have a WPF team, we have a JavaScript team. We have a team that maintains the C++ engine underneath, and we have a mobile team as well. So it is a small company, but we have 15 developers working full time. In addition to that, a couple of marketing and salespeople as well, because we are a commercial entity and we need to make a living from it. But this is it's our bread and butter, and it's something that we've worked on obsessively for a long time. Almost 15 years.
Obsessively is the right word.
Right. And I would say, I've said before, a labor of love, but I mean, I myself, I have a development background, and in the last couple of weeks, I have been really digging into the SideChart.js code base saying, okay, how do we squeeze more out of it? Yeah. And by enabling certain things such as WebAssembly SIMD and various other optimizations, we've managed to shrink the WASM file size by about 30%. And make it 2 times faster, So, you would think that from the kind of demos we have on the web, you think, all right, this is already fast enough. But we do have clients coming to us and saying, no, we need more.
Yeah. There's always more data. There's always and we love a challenge. When we worked with one of those big industrial monitoring companies who were doing this port, and they were like, well, we need to show a grid of 100 charts that are all synchronized together. And at the time, we thought we'd been clever by getting around the WebGL context limit, where you can only have 16 WebGL contexts in a thing, by saying, oh, well, we'll draw to a hidden canvas, and then we'll copy the result to the target canvas, and so you can have as many as you like. And then it turns out that actually that copy step is not very fast, especially in Firefox. It's dog slow for reasons unknown. So it's like, oh no, this is when you've got a lot of charts, suddenly that becomes the bottleneck. So it was like, okay, well then let's just have one big canvas and render multiple separate charts to it. And so we kind of created this whole new API called subcharts, where you could define multiple charts on the same surface, and then we figured out you could use that to do all kinds of cool things. Like you could have a chart as a tooltip. So when you hover over something, you could show like a little chart in that area, which people use to do, like you'd seen like volume profiles in trading apps, where it's like, well, on this candle, like this is the volume profile of that thing. You can do that kind of stuff. So and just when you think people have got enough data, someone comes along and says, oh, well, yeah, I've got this 500,000 point chart, but actually there's a whole bunch of parameters that go into this thing, and what I really want is several hundred variations of that same chart, all created like all at once, and so it's like, I'm sorry, what? It's like,
we had a customer.
No way we can do that on the client. So okay, we're going to have to do this on the server in some kind of batch process, and so looking at that kind of thing. So there's always more data, but we love a challenge.
There was one customer that came to us, and David was talking about the 100 chart example, where we were like, okay, goodness me. So I remember that David created the subchart API, which was this batching, sharing on a single canvas. And this was really awesome. This boosted the performance a lot. And then all of a sudden we were like, wait, the data labels, the labels on the axis. You have 100 charts. You've got 2 axes per chart. Each axis has 5 to 10 labels. So you've got thousands of labels to draw. And text rendering is notoriously slow, no matter how you do it. It's like, how on earth do we get around that? So then there were all of these algorithms that went in there about the caching of the layout and the drawing and the rendering of labels, so that you could share these across them, just so that you could bypass this limit. And we've got a demo on our site, and it has 100 charts in a grid, and they're all scrolling, and and that's superb. And then one customer came to us and said, hey, we're working in the semiconductors industry, and we want to display 3,000 charts on a single web page. And each one has 10 million data points. And we're like, you can't do that. And they're like, what do you mean you can't do that? And I said, well, just do the maths, right? X values, Y values, double precision, 8 bytes per point, 16 bytes per point. You'll need gigabytes, and you just don't have that much memory available. So you've got to use other techniques. So while we're here, sitting here optimizing, and people are looking at what we do and thinking, oh, that's great, that's really fast, it's amazing. That's probably overkill for me. There are clients out there that are saying it's not enough, right? And we're always having to go back to the drawing board. And every time we do this, it's like a multi-dimensional Rubik's Cube that adds another dimension, because you have to get the speed in there, but you've got to keep it flexible. You've got to keep it easy to use. You've got to make sure that there's no weird API with all these strange settings that you have to set. It just has to work. It has to be backward compatible. It has to be easy to explain. It has to not break anything for our existing users. So every time we do this, and we're going through this process right now.
Library dev is hard.
We add another layer.
Not like app dev at all.
And guess what? We can't even see the code that our clients are developing. So we have thousands of people out there using SideChart, and we've got to make sure that every single function call we add, change, every property that we change is a breaking change. So we can't do that, Every now and again we have to introduce breaking changes, but we don't like to, because we want it to be a seamless upgrade. But yeah, it's super hard.
But we're having next month. We've been on a big performance push just in the last month or so. We feel like we're, with all of the advances in WebAssembly, we still feel like we're barely scratching the surface of what's possible. So we've recently just got into. There's a number of places in the software where we need to read back the data that's in WASM in order to do sort of further processing in the browser. Like, I want to transform the data. I want to, take the data in this series, and I want to reshape it and to draw it in a slightly different way, in a custom way. And so I've got to read that data back. And we discovered that, if you just use the standard vector accessors that Inscription produces for you, they're really, really slow. Well, when we say really slow, relatively speaking, but compared to just sort of accessing an array or something, they're really slow. But then we discovered, you can create array views over the native WebAssembly memory and access them directly. You can just read the memory back. But those array views are really volatile, right? Anytime that the WebAssembly memory changes in any kind of way, all of those views get invalidated. So, and in fact, we discovered through kind of unit testing of these various different methods that actually, when you're doing like get me this value from the native array, what it's really doing is going create a view, index that view, throw the view away, like every single time. So we're like, we can just, if we're really, if we're careful, like we only use these things for within a loop in a short time, we can create the view, we can access it, and then sort of throw it away, and suddenly all of these routines get like 5, 10, 50, 100 times faster because we're doing this like unsafe, memory access. There's been some, a few blown off toes as we've been going through this, finding ways that to do it wrong, but some really exciting performance improvements coming as well.
The interesting thing is that all of these features are actually going back into the languages as well. That's what I loved when we did when we started with the whole WebM scripting thing and indexed arrays. We didn't have before in JavaScript, but now we actually have them, like UTF-8 arrays, clamped arrays, these kind of things. All the bits that came from other languages that JavaScript was always saying like, oh no, we make everything as flexible as possible, burning up memory in the same time. The same with like the off-screen canvas. We found that in browsers, everybody uses an off-screen canvas to just have a show canvas and a calculate canvas when you do image manipulation and these kind of things. And now it's basically, there's a offline canvas API coming, I think. So I find it very fascinating that these edge case use cases then can feed back into the platform itself. I'm actually worried about meeting people that want to see 300 charts at the same time. I mean, how do they compute it in their head? That's the more confusing thing for me. Is it just like we want to see everything at the same time, or do they really manage to follow?
We have said that, and we had a discussion with the customer that said our client, the one where I said our client wants to show 3,000 charts, and we know that that's a silly requirement, but they want it. And we're like, yes, that is a silly requirement, but I guess they want it and you want it, so let's work on that. I guess look, in certainly in the scientific industry, and look at where we're going with data, right? We've got an enormous amount of data being processed, recorded, chunked, read by LLMs, output, et cetera. Going to the use case of, say, the F1 car. The F1 car has 1,000 sensors on it, and those sensors are streaming telemetry data non-stop, right? But then that could expand to anything. It could be robotics. It could be sensors in your home. It could be health monitoring apps. It could be industrial monitoring apps. Yeah. So Internet of Things is kind of exploding the amount of data that we have, right? So yeah, I mean that's kind of where we fit. Is we're here. We're able to do this, even if it is a quote unquote silly requirement, even if it's a crazy requirement. I guess,
and I think what we're trying to push is actually these things which have maybe been seen as crazy requirements. Maybe they're not so crazy. Maybe there's real value in and real insights to be gained from actually having 1 million points live in the browser that you can deep zoom into, rather than just 50 that have been produced by some enormous kind of database analysis chain or something that you've got sitting in the background that runs on a batch process once a day. It's like, give me the raw data and let me look at it, let me drill down into it, and we can see things. So.
It's also not just charts on your desktop PC or on your mobile. I mean, there are some applications where you might have a control center which has got an enormous screen, right? And that screen is measured in feet, not inches. Yeah. And up there, you might want to dashboard absolutely everything that you can think of, and that's powered by a single high-powered PC with a Chromium tab. There are some applications that we've worked on where companies have had, say, a trading floor, and they have an enormous screen with every market is shown on the same screen, or all kinds of data about your industrial process or your server health or anything like that. It's not just desktop applications. So you think about these requirements where you have many charts on the screen. It could be an enormous screen,
And really dynamic stuff as well, and really highly customized stuff as well. So we know that there's a lot of people doing embedded stuff. So Andrew talked about medical devices. We're also seeing people embedding this in cars. So it's being used as kind of dashboard software, in particular in driverless cars and things like that. And in those situations, like you want that to have a very distinct look and feel, right? You don't want your visualization to just look like some generic whatever your standard library is giving you. You want to be able to really fine tune the look and feel of that thing. So for us, that customization is really important, and it's one of those things of software, isn't it? It's like it can be fast, it can be easy to use, it can be flexible. Choose one, or maybe two. But we really strive for all three, and that's the challenge.
I love that it has fashion as well. I mean, when GTK came out, everything looked the same, and I remember when macOS was all brushed metal. And fake buttons that looked like wood and these kind of things, and turn buttons that you couldn't turn, and it's these kind of things. When you say embedded systems, I just remembered like the PTSD crash when I had to work on Qt back then. That was like for oil rigs and like embedded screens that were like dirty and grimy, and you were able to do it in a storm in the North Sea. And it's interesting that computing gets into those spaces as well. Now, you talked about a WPF department. Let's talk about the WTF department. How much do you get in terms of feedback, in terms of pull requests, in terms of how do you deal with those? Like, it seems like a lot of people have requests. Do they come in through sales, or do they come in through like pull requests and comments as well? Okay,
so the ways that we interact with our customers are as follows. So we don't really get PRs because the SciChart library is not open source. The SciChart examples, documentation, demos, they are open source. From time to time, we get feedback on those, but not particularly often. We have a support desk that's on our website. So we're using a professional call center type support desk that our clients can sort of contact us at any time. They can open a ticket, and because we're a small team with 15 devs, we basically do a round robin approach, and it's actually the developers that built SciChart that are answering those tickets. So whenever there's a bug report or feedback, or we'd like you to build this, or we'd like you to build that, it usually comes in through there. There's also a forum which is open on the SciChart site. That's a little bit less used, but there's a public forum with sort of 4,000 or 5,000 questions on there. And recently we've also launched an AI assistant. So we've got basically it's our own system, it's in-house, and it uses a RAG-based system underneath in order to crawl our documentation, it crawls our examples, et cetera, and provides answers directly to users. So it sort of helps them to find what they're looking for and act as a pretty useful search/first line support. But if that's not providing the right answer, they'll typically come to us. And in customer conversations, let's say somebody has a very tricky requirement, and they want to find out, hey, can you do this? Usually they'll come to us and we'll have a meeting with them and discuss their requirements. And that feedback all goes back into the library because we're very, very much user driven. We're very much, we have our own ideas about what we think is cool and awesome, but at the same time, we want to be building things that are actually useful, that people actually want. So we take that feedback really, really seriously. It is a balancing act, of course, because you have to trade off the needs of other users with our own roadmap, with the performance requirements that we must keep, et cetera, et cetera. But we do our best to balance that.
There's commercial elements to that, right? We don't just build what people ask for. We kind of have to build what people are prepared to pay for. Because a lot of what people ask for, they're actually not prepared to pay for. It's like there's a difference between, surely it'd be really cool if you built this and loads of people would want it. Like, nobody else is asking for it, so it's a lot of work. So do you want to pay X amount for this? Well, actually, no. Okay, well then it's not that important. There's quite a lot of that as well from industries that will remain nameless. Sometimes difficult decisions have to be made about where we prioritize.
it's like when people come up to me and say like, oh, can you do that for free? And you get like exposure for it. And I'm like, yeah. And then I go to the butcher and ask for like some food for exposure, and I'm not going to get any. So this is not really the way it works. But yeah, it's an interesting thing. I also want to thank you for your documentation, because this is a lot of work and this is a lot of effort. And people could just use like an AI thing to actually say like generate documentation that means nothing. You put a lot of effort into it, and that feels like some of the older projects that I worked on, like YUI, was the same thing, that documentation is a super important thing. And hopefully it also means that people have less questions because they can have interactive documentation and you can point toward that.
And the AI thing is really challenging, actually, because we found this as we've been developing this RAG system to crawl our own documentation, as we've been as we and our customers have been using AI tools to build stuff with SciChart. Because we're a fairly small company, we don't have a huge amount of exposure. The traditional models are not super well trained on SciChart. They're kind of aware of it, but they're not, in detail. So you need to kind of give them quite a lot of detailed context for to help them along, and the AI assistant helps with that. But we found it fascinating about like, what do you need to do in order to really make a library AI ready? Like if you say, add me a tooltip to this chart, and the AI goes, okay, new tooltip modifier, and you go, oh, hang on a second, we don't have tooltip modifier, we have rollover modifier and cursor modifier, and suddenly you think, have we just named that really badly? Like, it's like, should we be changing it to sort of match what the AI thinks it should be, or is that a documentation problem? Do we need to be creating more examples and things in order to show this kind of stuff? So it's really forced us to think really hard about some of these API decisions and how we do this stuff. So that's a very active area of research at the moment.
If I can add to that, I would also say that we're super motivated to have good documentation, because if we don't, people are going to come to us and ask questions. Yeah. Right? We want to make sure that everything that the library can do is documented and documented well. And you talked about the effort that went into that, right? I'll give you a little sort of snippet or insight. Recently, we completely reworked the documentation for SciChart.js from a commercial tool into Dockersaurus, which allowed us to write the docs using Markdown, which means any developer can now, or any public person can now pretty much submit a PR and just say, oh, there's a typo here, this needs to be changed. But one thing that's difficult to maintain is having code samples in the docs that are accurate and actually work, right? So if you copy and paste a code sample and you stick it into your IDE, and then you find out there's a typo here, or the API is changed. So the code samples are actually pulled from a GitHub repo, from a bunch of compiled examples. So the whole documentation deploy process compiles those examples, runs them, checks them, embeds them in the documentation, and we're embedding code pens as well. So if you go into the JS docs, you can see live code pens right there that you can manipulate. You can click edit on code pen. It'll open up into a new tab. And all of this is crawlable, by Google, by AIs, etc. And there is a enormous effort here. And still, even when we do that, there are people who say, hey, this type isn't very well documented, or that's not very well documented. And we think, all right, we better go back and do that, swing back around and do it. Developers don't really love writing documentation. They want to be writing code, and developers, love even less answering support requests and support tickets from customers. So we present this to our team as this: hey, if you write the docs and you write them well, there's going to be less tickets. So that's kind of the motivation there.
Every question that gets asked that becomes a documentation to do, pretty much. So.
I found that myself. I started writing the docs before I write the code, because I also realized I do a lot of when I think about it, what the thing should do and what the end user then actually has to do with it. I realized there's a lot of stuff I don't need to write. But when you said like when people use code generation and it actually hallucinates like APIs that aren't there, I've seen companies do that right now that actually get PRs of like extending their APIs because of things that Claude or other editors actually do, because rather than having an error, it then does something useful with it. But it feels weird that we're feeding back to the machine that comes up with hallucinations. But it's an interesting world that we live in. Well, I mean,
we want to be careful about changing the API because I'll give you one example of an API that the AI hallucinates. So in SideChart, we have the concept of renderable series, which draws your chart, and then data series that stores your data. And the data series, you pass it X values and Y values as a typed array or a number array. If we want to get those X values and Y values back, because they've been passed to WASM, we have a function called get native X values, get native Y values. And AI continually hallucinates that, oh, it's just data series.x values, and it's not. That's not a property. Now, we could put a property on there. It's not a breaking change to add a property, but it changes our docs. Or we could improve the docs and put extra context around it. You know? There's other things that you can do, like you can feed LLMs, LLMs.txt with info about common gotchas and caveats. But yeah, when we write our docs, we're not only making sure that they're human readable, we're also making sure that they're AI readable, that they make sense, that they're well structured, well explained, not too verbose, but they have enough detail to give humans and machines the context that they need. And there's also things about naming conventions that we have to think of. So for example, if let's say you wanted to draw a chart and you want each data point to be colored differently. We have an API that does that called the palette provider. You can pass a palette provider to a series, and the palette provider has a function which you can then run, and it will send the colors back. But it's not called color by data points. So depending on what people are asking us, we're putting into our docs, this kind of phrasing, like change the phrasing like this. Like, how do you color data by data points? You can use this to color data points, et cetera, right? So writing your docs in that way so that you get fewer questions and so that AIs are, more up to date,
But you don't want to alias it either, because I mean that goes into PHP land. And I remember when that was basically like we had 5 functions doing the same thing because people just kept typing it wrongly. And but that is all overhead and computational overhead as well, that you probably in an environment like yours makes no sense at all. Well, this is delightful. This is amazing. I mean, we have a performance and AI live day coming up, so it might be interesting to do a talk about that. But let's do that. Let's think about offline what we could do there. But the last thing I want to talk to you about, like, what would you like our listeners to do? Do you need any feedback? Do you need testing? Do you need contributions? What would you like people to stop saying about SideChart, and what would you like them to do with SideChart?
I'd say basically raise your expectations about what is possible on the web. We will be conditioned to think that web charts have these limits, that you can't do this, you can't do that, you can't show this many points or this many charts, all that kind of stuff, or that you can't have it exactly the way that you want it. And actually, you really can. And so we would challenge people to say, go and try SideChart. SideChart.js has a community edition. You can try it for free, no sign up, no anything. It just works. There's a watermark. It's literally full features. The only restriction is the watermark. And have a go and see what you can do. Challenge yourself. Challenge the library. See what breaks. See what you like, what you don't like. Like I said, we love a challenge. There's our business has been built on kind of making the impossible possible, but people doing things that they didn't think that they could. And we really want developers to have that wow moment of creating something that just is really cool and solves a problem and delivers something that's really impressive. So so just try it and challenge yourself and challenge us and see what's actually possible, because the chances are that it's a lot more than you think.
That was Coffee with Developers with David Burleigh and Andrew Burnett-Thompson ... from SciChart. And we actually talked about the uncharted territory of WebAssembly and performance on the web with charts. So take a look at SciChart, and we see you next time at Coffee with Developers. That's it from me. Bye-bye.